Okay, welcome everyone. This webinar is brought to you by the North East Catchment Management Authority and Agriculture Victoria. And we're going to hear from myself, it's Brad Costin, and also Ethan Berry and Graham Anderson from Agriculture Victoria. And we'd just like to support the Australian Government here and the National Landcare Program for helping fund this webinar. And we also acknowledge the traditional owners of the land at which we work, and we pay our respects to their elders past and present, and also to the CMA's Indigenous staff as well. Just importantly, if you can have a go at filling out the climate knowledge survey, which was the link was embedded in the email registration for this webinar. You can have a go at filling out that at some stage. That'd be most appreciated. And just in case people do come on throughout the webinar, it is being recorded, which is good. So if if your kids have hogged all the internet and it bombs out, there is a good chance you'll hear a bit about this. You'll hear it through the link being sent post webinar. So yeah, just hopefully everyone's all comfortable and has their cuppa or other beverage. And look, I reckon I'll pass it over to Ethan just to go through some housewarming.
Yes, g'day. Welcome everybody. Just wanted to run through a couple of housekeeping things regarding Microsoft Teams and how this is going to work this evening. So Brad, if you wouldn't mind going back to that slide for us, that'd be great. Yeah, we are going to be trying to keep our mics muted for this. And if you would like to ask a question, feel free to either raise your hand with the raise your hand function there and we'll unmute your microphone, or you can also submit a question there in the chat box and we will get to that too. You can mute and unmute your microphone in the menu down the bottom there. And if you're having any trouble with audio or microphone or anything like that, try looking in the three dots there, that more options menu, show device settings to check your speaker and microphone, or as well, if you'd like to turn on some automatic captions for the presentation, then that option is in there too.
Fantastic. Thanks, Ethan, for those housekeeping ones. And we will use that message box function at the end for a bit of feedback from people. So yeah, we will remind people about that one. Let's just sort of go through what we're going to get into this evening. So really, we're just going to start off just with Ethan having a bit of a talk about the Upper Murray historical sort of rainfall and what it's about, and then I'll go into a bit of the climate driver overview. So that's a bit of a crash course in climate drivers. And then once we've done that, we'll see sort of Ethan also then talk a bit about those climate drivers on rainfall from around Corryong, and then we'll hear Graham Anderson talk about sort of the short-term seasonal outlook, and then it'll come back to myself for some considerations for livestock producers. So it's a bit of a tag team and a team effort. And look, and then at the end we'll also have a short an opportunity for people to ask questions, so they can sort of use the chat box there, or the mic, speak on the mic if they want at the end, which would be great, and then just a short evaluation as well. So that's what we're going to get into, and so I'll hand over to Ethan to start off on the Upper Murray rainfall.
Cheers. Thank you for that, Brad. All right. So we're going to be, first of all, I want to give a bit of a plug to the Climate app. If you haven't heard about this app or this website, it really is an excellent place to get your most up-to-date information about how your rainfall is tracking for the year. So this is a screen grab I grabbed yesterday of the past 5 months. This red line here shows how we're tracking so far for the past 5 months, and the blue line, the thick blue line in the middle, is the average for Corryong. And I've centered all of this data around Corryong today to be somewhat representative, hopefully, of the Upper Murray region. All of these light blue lines that you can see there are individual years. So you can see the spread there of what rainfall has been like for the region. and how you're tracking for the past 5 months, and you can change this number here. The next slide shows what we're actually like for the past 12 months. So 2019, obviously pretty dry year, and we're still recovering from that, but with a bit of the rain here, you can see these big rain events here stepping up over the past few months, bringing us a little bit closer to that thick blue line there for Corryong. You can get this app here on any of your app stores on your phones, or you can also get this through the Climate website too. And just in the bottom left here, you can see these are just to show you a bit of an idea of how many locations there are. You can get data through this app. Pretty flexible way to take a look at historical rainfall. But diving a little bit further into what things have specifically been like for Corryong since records began, let's take a little bit of a look at what this rainfall's been like. So average rainfall for Corryong is 780 millimeters every year. But you can see from here, going back to about 1892, it's incredibly variable every year, varying from about 400 mils all the way through to 1200 mils. So really, how many years, how often do we get an average year around 800 mils? Maybe one in every 10 years, one in every 5 years. And you can see some of those much wetter years. You can see 2018, 2019 here off to the right, being pretty dry. And then 2016, you can see is the most recent really wet year. You can, looking at this, a graph like this, really see some of those heavy hitting extra dry or extra wet years. And then kind of breaking that down by season a little bit more, you can see that for Corryong, looking at winter specifically, probably is the least variable rainfall season of all of them, and autumn and spring really capturing a lot more of that variability over the past couple hundred years since records began.
Good stuff. Thanks, Ethan. So yeah, really, the big part of this webinar is about the influence of these climate drivers on sort of local rainfall. And I suppose it is fairly, it might be simple and most people might know it, but really it's the fundamental to really appreciating the effect of these climate drivers is really the ability of warm air to hold a lot more moisture than cooler air. So what you're seeing in front of you there is a bit of satellite derived data of a map of the world, and you've got Australia down on the sort of the right hand sort of corner there, and that sort of green band that you can see through the middle, which is sort of mostly centered around the equator there, is moist air. And so this data sets the total precipitable water in the atmosphere there. So as you can sort of see, that brighter green is sort of getting towards that sort of 60 and 70 kilograms of water per cubic meter of air, of atmosphere there. And so as we know, it's warmer near the equator, and that warm water evaporates. Warm water evaporates more readily than cooler water, and so we get a lot more moisture in the air at those locations, and that's really a big influence on the rainfall that we get down here in southeastern Australia. And look, there are other sort of climate mechanisms such as the southern annular mode and east coast lows, which are really important sort of triggers on bringing some of this moist air to us down in southeast Australia. But the fundamental thing and the most, the first thing is having that moist air from the tropics to feed down here into a sort of southeastern Australia. And so it's really that these tropics are the engine rooms for moisture, and there's a lot of warm water there and a lot of moisture in the air, and that's a big determiner of who gets the rain and where. And so we're going to really hear about sort of two of the main sort of climate drivers, which, as you can see up there, are the El Nino Southern Oscillation, El Nino, La Nina, and also the Indian Ocean dipole, and they will strongly relate to the information that Ethan's going to present later on. And so, if everything's going well, you're looking at a very colourful map of the world flattened out in front of you, and this is a sort of a sea surface temperature map, but it's not, the colours represent the temperature, but it doesn't actually represent the actual temperature in degrees of the water. So the map that you've got in front of you here is what we call an anomaly map, and it's really about a map that shows how much hotter or colder that water is than it would be normally for that time of the year. So if you have a look just on that scale bar down below there, you've got sort of red being in that sort of 4 and 5 degrees warmer than normal, through to the blue being cooler than normal, a couple of degrees cooler than normal there, if you get your eyes in it. And I suppose really understanding that El Nino and what La Nina do is sort of move these bodies of warmer water around a bit, and when we get El Nino, that warmer body of water sort of gets pushed away from Australia towards the South, the Americas, South America there, and with an La Nina year, it would be closer towards sort of northern Australia there. And it's, I suppose, the real thing. It's important to really know. It's just the difference, the normal or the anomaly that help us understand if it's an El Nino or La Nina event. And it doesn't have to be a huge difference or a huge change, really, in water temperature for that to occur. And so you can see there's these couple of big circles on the map in front of you there, and these are really those critical sort of zones in that sort of middle Pacific there that you can see for identifying an El Nino, and it's the sort of the change in the average or the normal temperatures that's important in forming an El Nino in that sort of central Pacific area. And just keep in mind, there's also a bit of an interplay with trade winds that influence and cloud cover that really influence whether it's an El Nino or a La Nina or a neutral event, as we see. So this is a bit of a crash course in climate drivers, so we won't sort of go into too much detail, but if you do want to learn a bit more, the Climate Kelpies, which you'll see a link at the end of this presentation, is a very great start. And so that was a El Nino year that we saw previously. And so what we're sort of seeing here in this same type of sea surface temperature map is a La Nina year, and this was taken in 2010, as you can see up here, and we had some wet years around 2010 and some wet summers also around, spring summers also around 2011 as well, around there. And so you can see that we've got this for here over Australia, we've got this warmer than average water. So we've got warmer water, more evaporation and more moisture in the air to feed down into southeastern Australia. And sort of opposite to that in the central Pacific there, we've got this cooler body of water there. So there's less moisture in the air, and that's where sort of South America starts to experience sort of drier than average conditions as well. So they're the key real concepts to think about with El Nino and La Nina as you hear about them later on in the presentation. And the other thing you'll hear about too is just the Indian Ocean dipole. So this is another important sort of source of moist air for Australia as well. And here's one taken in 2006, and that'll be in most people's memories of how dry it was there. So with an IOD, which is our Indian Ocean dipole there, for an IOD positive sort of year, we've got cooler than average water around northern Australia, and it's sort of measured relative to the water temperature towards Africa there. So that's when we get an IOD positive year, that warm water's pushed away, and we can experience sort of below average sort of rainfall. And then if we'll just go back to an IOD negative, and as you can see, water temperatures, again, it's the anomaly, so it's not the actual water temperature, but the water temperature's changed. The anomaly, the temperature relative to normal's changed around. So with an IOD negative, we've got warmer water to the north of Australia as well, which can set us up for some good rainfall conditions down here in southeast Australia. There's just a few considerations and a few things to be aware of, or caveats maybe, for people to think about when they hear these sort of terms. And so we can get, and as Ethan will show, some of these pairing of some of these events, so they can sort of tag team up and be a bit of a double whammy and create a bit of strife for us down here with rainfall. So it can happen that we can get both, El Nino and IOD positive years, creating some dry conditions for southeast Australia, and it's not really working for us there for rainfall. And another consideration is also about the seasonal timings of El Nino and La Nina. Spring and autumn are certainly times to be thinking about whether or not we've got El Nino and La Nina's forming. And the actual strength of the signal in which scientists sort of derive the El Nino or La Nina or IOD sort of climate drivers, and sometimes the strength of that signal isn't as strong or convincing, and we can sort of end up with these neutral years where there's doesn't actually mean average, but it just, when they're sort of where it's neutral or no signal, there's still a chance of some of these climate extremes, and so that's something, it's a real caveat there, and to be thinking about when you hear about this in the news as well. So we're just going to pass over to Ethan now. And Ethan, you want to take us through what that actually means for the Upper Murray?
Yeah, totally. Thanks for that, Brad. And thanks for running through those climate drivers. We want to take a look at how that has actually impacted specifically Corryong and get really local with this data and see what impact these drivers have on local rainfall in the Upper Murray. And so what I've got on the slide here is each of those 4 climate drivers are put on a chalky wheel here. So off to the left, I've just tried to show you what a standard chalky wheel looks like. So if you were to take all of the years on record in Corryong and split them into 3, we would say that those red third of years are our dry years, the blue third of years is our wetter years, and the yellow third of years is what we'd call our average years. And so, we're splitting the data set into what we call terciles, so splitting it into 3. And so what we wanted to look at is to see, in all of the years on record, of the years where an El Nino was present, what did that do? And that shows in that top left chalky wheel there, it shows that 65% of the years on record landed up being drier if there was an El Nino present. And on the other hand of things, in Corryong, when it was a La Nina year, 52% of those wetter years happened when there was a La Nina, and the same can be seen for the IOD, the Indian Ocean Dipole. When it's in its positive phase, 63% of the years on record can be found when an IOD is in its positive phase, and 63% when the IOD is in its negative phase are wetter years too. So it's really nice to be able to see how much of an impact these climate drivers do have on local rainfall and really crunch those numbers. That's for the whole year. I've also done it just to show what it's like for our typical growing season, sort of between September and November. And the numbers are pretty similar, although you can see that La Nina, it goes up to about 58% of years fall into that wetter category when La Nina is around. So these climate drivers really do have quite a profound influence on rainfall. But just like Brad was saying as well, when we have a year where there are no climate drivers around, it's not an El Nino or a La Nina or an IOD positive or negative year, it's just a neutral year, we still can have some pretty surprisingly wet or dry years too. So what I want to do is I want to take us back to this graph where it sort of summarizes Corryong's rainfall and point out some of these more extreme years. And I'm going to overlay just sort of what's been going on here. So if we think back to 2016, off to the right here, that was actually a negative IOD year. Really did end up being a lot of rainfall coming in from the Indian Ocean because it was in its negative phase. Ended up being a pretty wet year, if anybody can remember that, in Corryong, getting about 1,100 mils that year. Thinking back to 2006, the Indian Ocean was in its positive phase. That dipole ended up also being quite a dry year. So I've gone through and I've sort of circled a lot of these years. See, between 1973, 1974, 1975, there was 3 La Ninas in a row. And that really did show that there were 3 really wet years in a row there. So going through the records, you can actually see how these climate drivers have had a big impact. Although you might be able to see there in that big red bar sticking up between 1962 and 1972. That was 1967. It was incredibly dry, but it was actually, there was no climate drivers going on that year. So it's important to note as well that just because it's a neutral year doesn't mean that we can expect average rainfall either. Just going through as well, there's a really nice tool that you can find, and we'll give a link to this on the last slide too, but the local climate tool, you can take a look at, just like with the Climate app, a lot of different locations around the state and see you can actually line up these years from driest to wettest, and it will also show you what climate drivers were active in each of those years to kind of get a little bit more of an idea of how these, just how much of an impact these climate drivers do have on our local rainfall. It's pretty red down the left there when we have double up years, El Ninos and a positive IOD, when you get dry from the west and dry from the east, getting some pretty disastrously dry years too. And the same can be said for La Nina and negative IOD, teaming up together to get some really, really wet years in Corryong. All right, I think that does it for everything I wanted to show for the time being. Not quite sure who I'm passing over to. Is it Graham?
I think so. Yeah. So well done, Ethan and Brad. Thanks for introducing that. I'm just giving a bit of a plug here for. Hang on. That's going to be quick. So there's the Bureau recently brought out some 4-page fact sheets for each region of Australia that was really looking at trends and what's been happening in local rainfall patterns or temperature trends or trends with frosts in each region. And they were comparing the last 30 years to the previous 30. So there's a web link there at the bottom, just the Bureau /climate guides. And there's a great little 4-pager for Northeast Victoria. And basically saying in terms of rainfall being relatively stable up in your part of the world, while it's been variable, there's been no strong trends. Certainly you can go to other parts of Victoria, and of the last 20 years, there might have been 15 dry years and 5 wet, where it's been more evenly split up there in the northeast. It's a strongly winter dominant season. And one thing that has popped up is spring frosts have been a bit more common and have been occurring a little bit later, in the last decade or two. And the other thing is there's been more hot days and more consecutive days above 38. But there's some really good little graphs and information in there, so I'd recommend that as a good little fact sheet. I'm just going to introduce, while there's been some great talk there about the long-term variability at Corryong and also the influence of those climate drivers, and especially the tropical oceans of Pacific and Indian Ocean, they're important to help understand then, especially when it comes to looking at forecasting and the outlook in terms of what are those oceans up to this year and what's driving the current forecast. So this was just updated today by the Bureau of Meteorology. It's their 3-month outlook. So it's the July to September outlook there. And what these sort of maps are showing is, imagine it's basically the percentage chance of above median rainfall. So if you can see there on those darker colours, when you look at the on the map, those darker colours are where they might have run the model 100 times, and in those sort of places where it's darker, 70 or 80 of the model runs have come out, wetter than average. And in the places on the map where you see it being white, it's sort of closer to 50% chance above average. That means that half the models were saying, wetter than average, and half the models saying drier. So that's the sort of current outlook. And so most of them at the minute have got, they're sort of hinting that there's an increased chance of above average rainfall in the coming months. And I'll just give you a look. There's a project called the Forewarned is Forearmed, which is also looking at new forecast products to add to the Bureau's offering. And there's a lot of farming organisations and research development corps involved in that. So there's better forecast products in future. And one of the things is just looking at that map, which talks about above or below median. There's other ways to represent that same information. So here's an example of the graph on the left, that there might be a bunch of different model runs that have really spread out, and some saying drier and some saying wetter and some saying average. What that bar is across the side is when you've got an equal chance of above or below median, that might actually mean that for if you run the model 100 times for a location, there might be 20 in each of those little blocks there. So there might be a 20% chance of decile 1, 2, but equally there might be a 20% chance of 9 or 10. So when they say 50-50 chance, they're not actually guaranteeing average. They're just saying actually the models are spread out all the way from decile 1 to decile 10. So that's an important thing to note when you're reading these. And so I've just got a little pilot product here for that current forecast for Corryong. You can see here on the graph on the right-hand side, that's the current outlook for the next 3 months. So normally you'd see there you've got a 20% chance of decile 1, 2, but in the current outlook, so they've run the model 100 times, and instead of 20 being in decile 1, 2, there's only 10. So, and you could notice up the other end of the spectrum, decile 9 and 10, which is the wettest end of the years, rather than just a 20% chance of that. That's actually there's 30% of the model runs have landed there. So that's just showing that there's certainly a few more of the model runs that are picking up more moisture around. That's indicating increased chance of a wetter year. So that's good. The important thing to note is while those oceans, and we'll talk a bit about why they might be set up to be more helpful mood this year than they were in last year, which is exactly what we want. You still need the individual weather event then to come and drop that moisture over your farm. So that's why occasionally some places can still miss out, and then occasionally some places can get more than what they ordered. But anyway, that's a pretty favourable outlook at the minute. This is the current sea surface temperature map that Brad was showing some of those other examples, but you can see here in the Pacific there, some of that blue line along the equator is the sort of what's potentially could form into a La Nina later in the year. And one of the things they're keeping an eye on is that warmer water out in the Coral Sea just to the northeast of Australia. If that's hanging around through the winter and spring, that'll be a useful supply of moisture for us. There were some earlier forecasts, perhaps a bit more a month or two ago, that was being quite bullish about the outlook for a wetter year, and it was predicated on there being the Indian Ocean dipole in its negative phase. But for that to happen, we need to see that warm water not on the African side of the Indian Ocean, but actually shifting across over towards Indonesia. So that hasn't happened yet. So I don't think it's at the moment that's not lining up into one of those humdinger wet years. Just that it's in a more helpful mood than it was this time last year. Now, for those that haven't seen that, the Break newsletter, Dale Gray puts that out with Agriculture Victoria, and Dale does a fair bit of work. Each month he goes and trawls through 12 of the world's sort of leading climate modelers. So this is not only just looks at the Bureau's model, but he looks at the European model, the UK model, the Chinese model, NASA's got a model, and the US atmosphere, the Koreans and the Japanese. So they've all got these great models. And he looks at the part of little southeast corner of Australia on all of them, those models, and just tallies them up. So you can see here on that graph on the left, the current one, when he looks at the 12 models, there's 4 of the models are sitting on average for Victoria for the next 3 months. One that's a bit average or slightly wetter, and then the 7 of them that are thinking that our part of the world could be a bit wetter this year. So that's a good little product to check, because sometimes, one model might be saying one thing, but this is sort of looking at, is that the only model on it, or are there a few others? So that's free. You can subscribe to that. Just drop an email to thebreak@agriculture.vic, and you can get that mailed for a bit of a heads up. What we tend to find with these forecasts is that it's sometimes the forecasts are quite spread and there's no clear signal. And then other years, sometimes it's quite a clear signal. Like last year, there was quite a clear signal towards drier, and probably, more than half or 2/3 of the models were indicating drier when we were doing this sort of at this time last year. So it's nice to see them back on the right side of the fence. So I'm going to hand over back to Brad.
Hey, fantastic. Thanks, Graham. So yeah, look, given that some of the information Graham was presenting there about sort of some of the models looking, or quite a few of the models looking at a wetter than average outlook, these are just sort of some of the considerations in that sort of space, I suppose, looking at it from a livestock perspective and livestock producers. So with as we sort of know, and a lot of people might already know a lot of this and have been through this many times with farming, but wetter than average years, and the risk of damaging paddocks and degrading paddocks with soils through through pugging, and especially when they're wet and waterlogged. So that's sort of something that people might want to have to think about, and where they could move livestock off sort of susceptible or risky areas at risk of pugging would be one sort of thing to think about. And then from an animal nutrition perspective, just keeping up enough roughage for livestock, for cattle, and this is probably just with a good flush of growth. And this would be certainly more important for those in the Upper Murray that have had pastures sort of affected by fire or burnt pastures, and that have come back quite green and lush in their paddocks. And so we might sort of see sort of risk of bloat there, and particularly clovers come back quite well with sort of open, nice sort of bare ground and seed that's survived. So clover, there's certainly been a good response to clover. So just keep an eye on sort of bloat risk, and people might have different ways to prevent bloat through feeding sort of roughage beforehand, or whatever works for them. This might sort of be more of an issue in spring. And then also just sort of coming into, wetter, if we come into those wetter sort of scenarios and wetter springs, sort of just for people to keep in mind things like sort of prevention of pulpy kidneys, so using sort of vaccines that they'd normally sort of use for that would be another one, just with all that sort of lush growth there. And probably more for particularly keeping an eye on grass tetany for those sort of lactating cows that they've got at the moment. So people would be aware of that, and how to sort of treat. But if there is any questions, if you have any questions, certainly contact your local vet just on any of those as well. We're sort of going sort of well for time. I was just going to sort of, now that we're sort of towards the end of it, if people have some questions, now's your, I'll go back one. If people have sort of questions, feel free to sort of unmute your mic, or maybe put up your hand if you've got any questions out there. It was a bit of a whirlwind of information there, but certainly happy for people to throw a few questions away if you've got any at any time. You'll just have to make sure your microphone's all plugged in and that you've not you haven't muted yourself. So you'll remember at the start there's that toolbar that floats across the screen. If you have a question about any of this at any time, put it up there. Just on the screen you can see in front of you are just some of the links for the information and tools that we've spoken about today. So the tool that Ethan used to look at what years and what climate drivers were operating on those years is that local climate tool. So you can see the internet address for that one on there. As I mentioned a bit earlier too, the Climate Kelpies is a great resource just to get a good sort of overview of the different climate drivers. So if you just type that into some of your internet search engines, you'll get a good, you'll find that straight away. And the break there, subscribing to the break is a great way to keep up to date with, what the models are saying, and to hear Dale Gray and others give their brief on what's happening on there. And look, if there isn't any questions, I'm happy with that. What would really be good? We've got a bit of a evaluation form that'll pop up in the chat box here. So a bit of this is getting used to the new technology as well for people. So if you actually put your mouse on your screen, and you'll see it may already be up on your right hand side, the meeting chat, but you can bring up the chat box, which is like the little talking bubble there, and you'll see a nice quick and easy link to a quick little sort of evaluation form, which is just push a few buttons and type a few words. If you can fill in that would be great. And look, we'll send a link of this recording to people that have registered, so you can go through some of this in your own time and at your own pace, which sort of helps because there's a fair bit to take on board on that one. So yeah, look, if there isn't any sort of questions, I'm happy to wrap it up. I suppose I was going to say thanks also to everyone for jumping in and attending, and also just again thanks to those sponsors, the Australian Government and the National Landcare Program, North East CMA, for the funding in the project. So if there isn't anything else, I'll give people a couple of seconds, and otherwise we might wrap it up. No, silence is golden. Graham or Ethan, is there anything else you wanted to add before we jump out?
No, thanks everybody for coming along and checking out the presentation this evening. Please do fill out the evaluation. It's nice and short, just a few questions about the presentation and any improvements or feedback you've got for us. So we really welcome that, so we can help and improve future presentations. But that's all from me.
No, that's all good. All right, everyone. Well, thanks for that, and we appreciate your participation. Thank you.
Thank you. See you later.